In this video, I would like to talk about Coulomb's law and how do we know that it's 1 over r squared instead of some other number. So for instance, what if the force was actually equal to kqq over r to the 2.00000001 or something along those lines? What if it was close to 2 but not exactly 2? Would we be able to tell? And the answer is that trying to use a Cavendish-style experiment for this, it would be almost impossible to tell. We can tell that it's about 2, but if it were different in such a small way, it would be pretty hard to imagine that we could figure that out. But we have a new technique now using the rules that we have for Gauss's law and conductors that we can use to test the inverse square law to an extremely high precision. Okay, so the first thing is that we showed before that Gauss's law implies Coulomb's law. So while Coulomb's law is pretty tricky to test, Gauss's law might be a lot easier to check. And in particular, we derived those conductor rules from Gauss's law. Okay, so if Gauss's law was wrong, then Coulomb's law would be wrong as well. Okay, so the experiment that we can do to check whether these laws are true or not is the following. So first we can take a conductor like so and hollow out a cavity inside it, and we can have a protrusion inside like this. Okay, so if I put excess charge on this conductor, then it's all going to move to the outer surface according to the conductor rules. And so none of it should be anywhere on the inside of that cavity. And what that means is that since the electric field is 0 inside the conductor, it should also be 0 inside that cavity. If, on the other hand, Gauss's law is incorrect, then we would expect to see some charges on this inner surface. Okay, in that case, it would be beneficial for there to be charges there, then they're getting further away from the other charges. Okay, so what we want to do then is put an enormous amount of charge on this conductor. Maybe we have like sparks that are flying off in various directions, like so. It doesn't matter, as much charge as we can possibly put on that conductor, we should still see no electric field inside. So by doing a simple test where we check for that, we can get an extremely high precision measurement of whether Gauss's law is true or not. And people have done experiments along these lines, and what they find is that that is in fact the case. Gauss's law appears to be true to our ability to measure it, which means that if the inverse square law was actually something like r to the 2.00000000 something, that number would have to be extremely small, something like 17 zeros after the 2. So to the best of our ability to measure it, Coulomb's law is correct and Gauss's law is also correct.